So for parametric integration, it's not a simple case of just making a Cartesian equation by combining these together and then differentiating it. That doesn't work, okay? It's a very long method and there's a much easier way to do it. So the question asks us to find dy by dx. So we're going to use a method called separation of variables. So we're going to take dy by dx and we're going to split it up into dy over something times by something over dx, because as long as these two things are the same, then they're going to cancel out, right? Now our other letter is t, which means here we're going to put dt and dt. And the reason both sides of the equation are the same is because once again dt and dt cancel out to give you dy over dx. Okay, so what's our next step? Well, now we know that y is t cubed minus t. So if we want to work out what dy by dt is, we just differentiate this. So t cubed becomes 3t squared and minus t becomes minus 1. So straight away, dy by dt we can replace with 3t squared minus 1. Now, we also know from the question that x is t squared plus 1 over t. However, that 1 over t I'm going to rewrite as t to the minus 1. Which means dx by dt, if you differentiate it, t squared becomes 2t, t to the minus 1 becomes minus t to the minus 2. But look at this, we don't want dx by dt, we want dt by dx. So we're going to flip this, so we're going to get 1 over that, so t, 2t minus t to the minus 2. And then by multiplying these two, remember this is essentially over 1 if we do it as a fraction, so we can just do this over our denominator. So our final answer for dy by dx, if we multiply those two brackets, becomes 3t squared minus 1 over 2t minus t to the minus 2. And then that is how you differentiate with parametrics. So let's look at a slightly harder question involving some exponentials and some natural logs. Okay, so what would we do? Well, dy by dx, let's split it up again. Our third variable is t, so it becomes dy by dt multiplied by dt over dx. Well, y is ln of 1 plus t squared. So dy by dt, if we differentiate that, to differentiate a natural log, differentiate the inside, so that's 2t, and then divide it by the original bracket, so 2t over 1 plus t squared. So straight away, that's dy by dt, so we can substitute that in place in our equation. So our equation for dy by dx would become 2t over 1 plus t squared. Now, we need to find dt over dx. So let's get rid of all of this. X is equal to e to the t squared. So if we differentiate that, to differentiate an exponential, you differentiate the power to get 2t, and you literally just multiply that to the start. So 2t e to the t squared. But remember, we don't want dx by dt, we want dt over dx. So we have to do 1 over 2t e to the t squared. Now, when you multiply, you see here it asks you to simplify. So diagonally, remember you can cancel things out, right? 2t and 2t, that cancels out. Meaning you can get 1 over e to the t squared multiplied by 1 plus t squared. And that is our final answer for dy by dx. So remember, when you differentiate, it's really easy. Dy by dx, split it up into dy by dt times dt by dx. But this can be anything. This can be d theta and d theta as well. This question, all of these questions have come from our A-level maths pack. So if you do need any help, go to this website and you'll find everything you need. They come with tons of worked solutions, and then right at the very end, there's loads of exam questions to put what you've learned to the test as well.